I'm Stephen Foskett from Gestalt IT, and we are here at Flash Memory Summit in Santa Clara. We are connecting with some of the industry groups that are developing all the stuff that we use in the data center. And there is, it would be hard-pressed for me to say that there is a technology that is more important to the construction of modern systems than PCI Express. And that's why I'm really excited to be here with Richard Solomon. You are with the PCI-SIG. What is that?
So we're the standards group that actually develops the PCI Express specification.
Okay.
And as I'm sure most of your viewers are aware, we need standards to make sure that everything works together, right? You want to go down, buy a computer from one company, a graphics card from another. You need that all to work together. I guess we're Flash Memory Summit, which is about storage probably, right? So you want to buy an SSD from one company and a server from another, and you want those all to work together. So we're the organization that does that. We develop new versions of the spec.
And I think one of the most remarkable things about PCI Express is, and PCI, is that this is a standard that goes back decades. And, and you have maintained compatibility. Well, not probably you, but the group has maintained compatibility literally for decades. I have a PCI-X networking card that I still use.
Oh my, yes.
And in an old machine, and basically anything that ever worked in PCIe still works in PCIe. That is crazy talk.
Yeah, all the way back to 2000, 2002 timeframe. And that is one of the hallmarks of the PCI-SIG, is that cards you designed and built back in 2000 will work. You can plug it into one of these brand new PCI Express 5.0 systems. That card will come up and work.
And even today, we have motherboards that come out with a freaking PCI slot on them, let alone PCIe. But I think that it's really remarkable. So tell us a little bit about the history here and sort of up to today. Where are we with PCI Express?
Well, you don't want to be here all day, so I won't go all the way back. But we started like PCI Express 4.0, right? I think most people are probably pretty familiar. It's 16 gigatransfers per second. You've been around the floor. There's a ton of SSDs out now that are running PCI Express 4.0. From 4.0 to 5.0, really the only change that we made to the spec was to increase the speed, right? So we went from 16 gigatransfers per second up to 32 gigatransfers per second. And it was a fairly straightforward transition for the industry. Our next generation after that, and what we're just now starting to see, is PCI Express 6.0, and that adds a 64 gig speed. We move from what we called NRZ signaling to PAM4 signaling. Gets a lot more complex electrically, so it's a lot harder for people to do, but it maintains that full backwards compatibility you were talking about, right? And even with the 6.0 spec, people can still design their chips to the lower speeds, and they can still be compatible with the new versions of the spec. So you kind of have the spec version and then the new speed generation as kind of two separate pieces. But 6.0, I like to say, it's not your father's PCI Express, right? When that transitioned to the 64 gig, we changed a lot of the fundamentals about the protocol. We added what we call flits. It gets a lot more involved.
But you're still maintaining backward compatibility.
You're still full backwards compatibility. Yep, anything that's designed to that new spec, even if it includes the new speed or not, always works back down, all the way down to your 2.5 gigatransfers per second, original PCI Express.
Yeah, and specifically too, do you have forward compatibility?
Oh, absolutely.
So that means that you can use...
You can always use it forwards, right. And it's both ways.
Yeah.
The card slot has been maintained across time, so that from a server or home PC perspective or an add-in card, it all works. That if you were to pull out your old machine, you could grab a brand new graphics card, plug that in, or a brand new SSD and plug it in. Of course, it's not going to work any faster than your old machine's capable of, but it'll still plug in and work.
Yeah, and I think that truly, you don't use the word magic too often in technology, but this kind of compatibility is really, really remarkable. I've got to say, I built an AMD Zen 3 server.
Oh, now you're showing our age. Don't do that.
A really nice new server. I didn't have a graphics card with it, but I had an old one sitting in a box under the table. And it's literally like one of the oldest PCIe cards I have. And I dropped it in there and it freaking works.
Yeah, it just comes up and goes.
And that's just incredible. It's not great, but it works. And So, and PCIe is not just about the bus inside the computer either. I mean, we were just talking about UCIe, we've been talking about CXL, I've done a lot of talking about Thunderbolt. All of these technologies also leverage the work of the PCI-SIG, right?
Well, and a lot of those, CXL is another example, right? It's another specification that builds on top of the PCI Express electrical layer. They don't use our protocols, but the same physical layer that maintains that backwards compatibility, all of that, they use that to build, and people can build other protocols on top of it.
Yeah.
So yeah, no, it really is underlying so many of the technologies we use today.
So let's talk about the future here. So you are demonstrating something right here that I think people are going to be excited to see. Tell us what it is.
Yeah, so kind of behind us, you can see an example of, this is a complete PCI Express 6.0 system with the latest 64 gigatransfers per second. And it's put together by one of our member companies, and they're showing a root complex, so kind of a mini server. Back behind Stephen, you can kind of see there's a little single board computer up there. Yeah, there you go. It'd make a great Vanna, by the way. Beautiful. We should hire this guy.
Come on.
So you got a complete server there with a little single board Linux machine. Then the bottom half here is an endpoint, so it kind of mimics that storage device or graphics card. And on the screen behind us, you can see this nice green bar of data moving at full speed. So anytime there's a new spec, people are always asking, okay, but when's it going to be real? And there it is, it's real.
So when are we going to start seeing products that support PCI Express 6? Now, before we get there, I think it's important to know that one of the requirements to support the newest versions of PCI Express is that it has to be implemented by the CPU vendors, right? So we now have PCIe 4 pretty much in all the modern platforms.
Yep. And you should be seeing a lot of PCI Express 5 systems as well. They're the newer ones. And with my PCI-SIG hat on, I can't really talk too much about product plans, but I would say within the next 2 or 3 years, it's usually about a 3-year cycle. So when you start seeing 5.0 systems in production, you can figure another 2-3 years after that, you'll start seeing 6.0 systems in production.
How about 7.0?
7.0, and again, you make a great straight man on it's hard to see the banner, but we have announced 7.0 as our next generation speed. It's 128 gigatransfers per second. It builds on all the things we did with 6.0, so no new modes. It's just going to be another speed bump. The industry always gets kind of excited when we make drastic changes, because that backwards compatibility is more difficult when you upend the way the protocol works. But 6 to 7 is going to be a very straightforward transition. We're targeting around 2025, because I know you were going to ask, 2025 for releasing of that spec.
Another thing that occurs to me is throughout the history of technology, we've been talking about optical, and it's one of those things where optical is always the transport for the next generation.
Yep.
You, the PCI-SIG, recently started talking about optical PCIe. Tell me a little bit more about that.
Yeah, and it's an important distinction to make. We're not saying that optical is required to go to those next speeds. What we're trying to do is enable optical at all the speeds. So 64 gig and 128 gig, back to 16, 32, right? What we're seeing is there are places in the industry where they need the reach of optical, or they need the resiliency of optical. And PCI Express has always allowed it, but we haven't necessarily made it easy. So what we're really trying to do now is gather all the industry experts that know these many different optical technologies, bring them all together into a new optical work group that as you say, we just announced. And from that, we'll change as little as we can in the spec, right? Just make whatever tweaks are necessary to enable people to connect optical up. We like to say we're going to make PCI Express optical friendly, but we've not yet reached the point where we can't run the speeds. I'm old enough to remember when the electrical work group came back and told us, oh, this 5 gig, that might be the end of copper.
Yeah.
And since then we've done 8, 16, 32, 64. I mean, who knows?
So thank you so much for this discussion of PCI and where we've been and where we're going with PCI Express. Where can people learn more about PCI and the future of this standard?
Definitely. Check us out on all your favorite social media, PCISIG.com, of course, on the web. We're also going to be at Supercompute 23 here in Denver coming in November. So if you're headed to that show, definitely come on by, take a look. We'll have demos and more information you can get there.
Well, thanks a lot. Thanks for watching, and I know that you can also find PCI Express in a computer near you. I'm Stephen Foskett for Gestalt IT. Check out more of these videos on our website at gestaltit.com or on our YouTube channel, which is Gestalt IT Video.